for it. Okay. Before we move on to our extra practice today, I did want to take a moment and just go through questions. We did, I think, get a chance to talk quite a bit, but just there were like 2 of them that I for sure wanted to just address. We don't have to go through the whole problem necessarily, but I had a lot of questions on ones like number 10 and number 11. Just some things within those problems. First of all, remember that most of these rules are not going to be isolated rules. So we did just learn the chain rule, but this is still a function t times a function cosine. And if it bothers you that they're t's, you can change them. But when we're talking position, usually our variable is going to be t. So I would just get used to it. Okay. But that is product rule. The chain rule shows up in the middle of doing the problem when we take the derivative of the second function, but we start with product rule. So I have a lot of people that like, we're like out of the moment of product rule and we just like move on, right? Wait, we started that one yesterday in class, didn't we? So I can stop talking about it now. Is that what you're saying? Did we also start number 11 in class yesterday? Okay, well, those are the 2 I want to talk about. What ones would you guys like me to talk about? Anything from the assignment? 11 does not have product rule because what? Yeah, and the thing that messes with us a lot, especially when dealing with derivatives, is pi, because pi does not look like a number, but pi is a number. So if you see pi in your head, replace it with whatever your favorite number is, 2, okay? And then see if you would still think product rule or whatever rule you were thinking of doing, because it does not behave like a variable, it behaves like a number because it is a number. There's nothing from. You don't have no. Yeah, because a lot of times like I'll like bring all my constants and multiply them together, but I won't like write something twice in FOIL. Yeah, I can. So first of all, when I see a radical and I'm thinking derivative, before I ever even start the problem, I would rewrite this as secant x plus tangent x raised to the 1/2. And then again, when I rewrite it that way, it's easier for me to see the outer function could be done by power rule. And so our derivative on that, our outer function, now remember the 4 is kind of along for the ride because it's just a constant multiplier, but we would have 4 times, and then the derivative of the outside function, which is an x to the 1/2, multiply the 1 by 1/2, or I could have just gone ahead and multiplied the 4 by 1/2, and subtract 1. 1/2 minus 1/2 minus 1 is negative 1/2. Don't change the inside. Time the inside. Well, the inside is just a sum of functions, which means I can take the derivative of each of those individually and add my answers. So the derivative of secant is secant tangent. And the derivative of tangent is secant squared. Again, as always, we could stop there today. I love, by the way, the circuit training that you're getting today. We had one of those before. I love them because it kind of forces you to do things like search for an answer that is equivalent to it. I don't necessarily have to simplify it, but I have to find the one that's equivalent to it, which is so similar to a multiple choice question, right? I don't have to simplify. Now, simplifying this, I would drop this to the denominator and make it back into a radical. I would take the 4 times 1/2 and get 2. I could pull out a GCF. That's probably what would get happened. Whatever that means. Something like that. Yeah. Good. Anything else? Yeah. 16? Sure. I'm gonna get rid of all this so I have a room. 16, product rule to start with. We've got a function times a function. So I would take the first times the derivative of the second, and the derivative of the second is where we start seeing that chain rule show up. So I would do the outer function, which is an x to the fourth, 4x to the third, leave the inside alone, times the derivative of the inside, derivative of 2x minus 5 is 2, plus the second function, times the derivative of the first, which is power rule. And then again, just a cleanup process on this. The kind of what I was saying with Ella, I would maybe just take the 2 times the 4 times the x cubed, get 8x cubed, but I would not write that out in. That is like the first time I've ever heard an announcement like that. I don't know. I feel like it was a girl's name. Kayla is what I heard. Caleb. I have no. Clearly he is missing, because otherwise they would just call the room that he was supposed to be in. I don't know. It's bizarre. Search party. I feel like we need to stay in here and practice this stuff. Okay. We do not. Let's start here. You should be able to do this one. Okay, does this look familiar from yesterday? This was kind of our quote unquote special case that we talked about at the end, right? Chain rule, start on the outside. What is the derivative of cosecant? Negative cosecant, cotangent. Now, the inside does not change, but it now has 2 locations instead of 1, right? So I am not changing 8x, but it has to stay inside both functions. Then times the derivative of the inside, which is 8. Questions? It just always throws us off because there's 2 of the spots. Now, cleaning that up, remember that this is not, and I know I said this yesterday, but it is not distribute, right? It's not now 8 cosecant x and 8 cotangent 8x, right? It's all multiplication. We put it in there one time. You can put it at the front if you want, but I do not distribute it to both. Questions? Okay. This is about as complex as I can make chain rule. So good luck. I mean, you're going to do great. We'll go through this together. This is complex, and if you make it through this without a mistake today, you are like really doing well with chain rule. Really doing well with chain rule. This is the most complex multi-layer chain rule I could come up with. Yes. Okay. 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 White. Type in there. Or can I just type in the thing that I want to cover it up with? Perfect. Okay. That's what I needed. Okay. I feel like we can all answer this question. What is the outermost layer? X cubed. Let's start there. Okay. So, whoa. Derivative of the outermost layer, 3x squared. Okay. Now, the inside of that is not going to change. So that 2 minus sine squared of 5x is not changing, right? Chain rule. So I did the outermost function times the derivative of the next layer, which would be our inside function. Now, first of all, the derivative of 2 is 0. So I am actually just right now, I'm going to like pull this out of here. I am taking the derivative of 2 minus sine of 5x squared. Do you see what I did there? To help us see our next layer. So now I'm taking the derivative of this inside layer to put here. Okay, well, the derivative of 2 is 0. The derivative of what's our next outer layer? Yeah, negative though, negative x squared. You see it? So my now, again, power rule, 2 times negative 1 is negative 2. Subtract 1 from the exponent, it would be raised to the first. Keep the inside, which is this, the same. Sine of 5x. Okay. Then we go derivative of the inside of that. So our insides was the sine of 5x, right? Here's my insides. We're going to put its derivative over here. Derivative of sine of 5x. Outer layer is sine, right? Its derivative is cosine. Don't change the inside. Times the inside of that. Nope. Because the insides of that function, had I like shown it here, it would have been 2, well, negative 2 sine of 5x. The insides of that is what we were then taking the derivative of, which is just the sine of 5x. Yeah, was I right? That's pretty complex. Yes, that's a lot of layers. You have to remember what you've already taken, what's inside, what's outside. Okay. That's as ugly as it gets. Depends. So what would we simplify? Yep, so what would we simplify? First of all, I can multiply my constants together, which are 3 times negative 2 times 5, which is what, negative 30? Okay. This right here really can't change because it's in a quantity squared. So unless I write it twice in FOIL, it just stays 2 minus sine squared of 5x quantity squared, right? The only way I can change that binomial is to write it twice in FOIL, which I'm not going to do. We would really never do that. So I multiplied that and that, and so all I have left is a sine of 5x and a cosine of 5x. Order on any of this does not matter. Other questions? Okay. How do we do this from a table? Always seeing those tables in there. Okay. Y equals f of g of x. Now, I will tell you, if I knew what those functions were, I could just do the composition and figure out what y is as a function, right? That's what it's saying. It's the composition of f of g of x. I don't know what those functions are. Remember that statement today when you're working on your circuit trading, it'll help you a little bit. If I know the functions, I can just do the composition and then do the derivative. If I don't know the functions, I have to just follow our derivative rule, chain rule, if the function is created by a composition. So the derivative of a composition says, take the derivative of the outermost layer, keep the inside the same, times the derivative of the next layer. But what's kind of tricky on this is they ask us to evaluate this for 2, which means everywhere I have an x, I will replace it with a 2. And I'll tell you what's going to bother people on this. So again, just kind of follow what you're replacing here. G of 2 is 3, right? So I can replace this with 3. It equals 3. On the outside of that is still f prime. G prime of 2 is 7. So notice the difference between G of 2 and G prime of 2. That's just a 7, okay? Well, what's bothering people is we're supposed to be evaluating this function at 2, but now I'm going to go find f prime of 3. Well, because it's a composition, so I replaced that with what it equaled. So f prime of 3 is why that entire column or row is there, okay? Because I need that number. 5 times 7, and we get an answer of 35. Questions on that? Absolutely going to see problems like this again. We will always see problems like this. Okay. All right. I think I have one more for us. My one more that I have for us is this. These two I created and they look so similar, right? Just a tiny little change from the function that is on the left to the function that is on the right. But what is the difference in that tiny little change? What does that change about how I have to do the problem? What do you think, Joey? Yes. The first one, I have a function times a function, right? Because this has an x, that means that it is a function times a function, and we would have to attack this using product rule. Okay. Is 5 a function? That was a bad question. 5 is a function, but do I have to use product rule if it is a constant? No. Remember, constants are just along for the ride. Now, I do want to talk about that. Look at the difference in how we attack these then. Okay, I have to use product rule for this first one. So if I were doing its derivative, I would do first times the derivative of the second, which is going to be chain rule. 4, subtract 1, keep the inside the same, times the derivative of the inside, plus the second, times the derivative of the first. Okay, clean it up because we always want to, right? 4 times 2 is 8. Okay, compare that to how I do the next one. All I have to do on the next one is just chain rule, right? I do not have to do product rule. That I take chain rule, my outer function is going to be 5x to the 4th. So 5 times 4 is 20. X to the 3rd times the derivative of the inside, which is 2, and we get 40 times 2x plus 3 cubed. Now, I've seen this happen a couple times, and I just want to show you, what if I didn't realize? I see that I could put a multiply between them. What if I said, ooh, I need to do this using product rule? Will I be wrong? Okay. If I attack this using product rule, I just want to show you, it's a lot of work. It's not that much work for this one, but it is more work. First, times the derivative of the second, which would be 4 2x plus 3 cubed plus the second. Oops, I've in my haste here. Times the derivative of the inside plus the second times the derivative of the first. And this is where it'll throw people off if you do this incorrectly. What is the derivative of a constant? 0, which means this will always be 0. Okay. And what happens is a lot of times we'll see a 5 and want its derivative to be like 1 or something. It would make this entire term go away because I'd be multiplying it by 0. So 2 times 4 times 5, 2 times 4 is 8, times 5 is 40. Do I get the exact same answer? I do. So yes, we are doing product rule, but unneeded if the leading coefficient is just that, a coefficient, not an x. Questions? Okay, you guys have the circuit training worksheet, which I do have printed out for you. Only homework. Okay, so you're just going to work on this for the rest of the time. However, I'm going to help you with a couple algebra ones, which I have over on the board over there. But I just want to, oops, that's not what I meant to do. Help you with this a little bit because on one of the problems, actually this happens twice. 2 of the problems you end up with, so something like 4x plus 5 to the negative 1/2 plus the square root of x plus 5, something like this, okay? As I'm cleaning it up, this would drop to my denominator and become a radical. With me, okay? They do not have an answer like that, which you're not going to find. What they do is they then look at this as a fraction, 2 fractions. They get a common denominator by multiplying this one by x plus 5. Yeah? So that I can add things together to make it 1 fraction. So when I take square root of x plus 5 times square root of x plus 5, I get x plus 5. Plus the 4 that was already there, and it would have been x plus 9 over the square root of x plus 5. That's what you would see as an answer after you've now taken your derivative and think that this was your answer. Happens at least twice on your worksheet is that they will get a common denominator to add the 2 fractions together, and that common denominator involves a radical. So there's some trickier algebra. And also the very last one, I have it on the board over here, but the very last problem starts out as cosine of x over sine squared of x, which would be quotient rule, but the cleanup process is crazy ugly to find the correct answer. And so what I did is I used my trig identities and the fact that sine squared is sine times sine. Okay, well, those 2 fractions would actually simplify to cosine over sine is cotangent. 1 over sine is cosecant. And now it's a product rule problem instead of a quotient rule problem, and way easier to do and way easier to clean up. Okay, so this is the very last one. Go ahead and change it to cotangent and cosecant, or it's going to be super hard to do. Okay. Rest of the time is yours to work, and I actually did just upload an answer key, so you can follow my work. I would advise trying them on your own first,